We will continue talking about the discussed subject, joint presentation by Andrey Kochetov from Huawei, joined by the chief expert at Sber Devices, Tatiana Shavrina. Good day, everyone. Well, in the framework of this workshop, we're going to touch a very exciting subject, automatic code generation. Will all of the coders and programmers and developers be replaced, or we're just solving a particular business task? Year 2021 for ML was marked by a new popular term, PLP, or Programming Language Processing, similar to NLP, Natural Language Processing. And there's been a big conference, KDD 2021, introduced the subject, coined the subject, making it a major theme of the conference. So, processing of program code similarly to natural language. Technological maturity for NLP today actually is so high that it's possible to automatically train the popular model a bit like BERT, like GPT-3, Roberta, T5, etc. Those architecture based on transformer architecture can a bit taught using machine code, and then we can apply those tasks for particular hands-on programming tasks, such as code generation, code extension, like T9, similarly to T9 vocabulary, code classification, search for vulnerabilities within the code, and also translation from speech in natural language into the code. So a ton of applications, and they're all made based on existing models. And there's complete inheritance between NLP and PLP tasks, major one being code generation. But we can generally group these tasks into three major groups. Related to the architecture, transformer architecture, we have transformer architecture that consists of encoder and decoder, and we have good tasks for the encoder, such as code classification. So, where the code is written out in pip8, where's the commentary, where's the code, how we can change something, find vulnerability, all of this is for the encoder. For the decoder is the task for code extension, sequence, continuation. The text might be in English or in Python or in Java. Models don't care much. We can train them all the way possible without changing architecture. And then code extension and even writing code according to given comments. That's also a task for decoders. And in the end, a very important task that's made based on transformer architecture, which is encoder plus decoder, which is similar to machine translation in the code. For example, translation from what needs to be done in a written brief, then it's transferred into the machine code. Or, for example, that includes writing code based on minutes. There's also machine translation of the machine code when we translate from Python to Java and vice versa, depending on the business task. Naming those tools independent would not be possible. No one can replace a real coder with transformer model. However, these models make a very important element of automation into our daily tasks. We all love to automate. Why wouldn't we make a model that will write auto tests, for example, the model that will write the simplest tests, and we will be getting deeper into that and tune it up. Or a model that will transfer style, or a model that will translate to PAP8. All of that are beautiful solutions that are accessible today, and they are flourishing. Code completion task, another thing that AI can do. This is the task of the project that we're talking right now, code completion. We are actively developing the solutions, and I'm happy to inform you that Sberbank, together with Huawei, are leading, one of the first ones who are doing this in Russia. And at the moment, our first prototype is being deployed at the language like Python and Java. And our first model that I will be talking about is based on RuGTP3 architecture. So what's code completion? How does it work? How it works? It's like T9 dictionary. It's like auto dictionary in your smartphone. Yes, for a start, this sort of technology was not very convenient and not very precise. When we had old phones, T9 often made mistakes and was the reason for multiple jokes. However, right now, when we are typing a text message on a smartphone, we don't even notice how quickly autofill works. The same thing is happening by code completion. It's even capable of forecasting quite long strings with different degrees of probability. Here's in the screenshot you can see first results of the built-in into IDE. Neural networks can capture dependencies, variable names that you have written in the code above, and it can suggest how to use it. And particularly, a very important thing here, very exciting thing here is the result that you may see. The comments written in the English or Russian language also make an impact on the continuation. For example, if you write, this program prints hello world, there's a suggestion to type hello world. And AI can also predict 3 options, depending on what it likes, I guess. And let's watch a brief demo video so we can see how it works live. Code to calculate number of lines in the code. These are our first prototypes working both Python and Java, and you can see how it looks like built in IDE. So on the right, there are normal hints from the IDE. And on the left, the code completion plugin. These are our internal experiments. Coder as opposed to code completion plugin. I mean, code completion plugin is normally 1.5 times faster. In our first prototypes, we have been using code from smart apps because we have a lot of those, and we want to make the days of the developers of smart apps a bit lighter. That's why we're mostly testing our developments on the smart apps. This plugin is also already available, and it will be available to a broader range, but for now it's available to smart apps developers in a smart app studio. And you can find there this plugin. It's called Jarvis, your assistant. Dear colleagues, thank you. Well, based on our initial experiments, almost 70% of hints that the model suggests were helpful. 49% of click were saved, 49% of saved clicks, so there's no need to retype the code, just selecting. 49% less clicks, which accelerates the code typing in Python by at least 50%, by 1.5. So we invite you to try our first developments at Smart Market Studio. In addition to decoder-based models, we're also actively touching transformer models because, indeed, it's not only about code completion. We can do something more than that, like classification, search for vulnerabilities, and other things like that. And here we're very actively using our current developments are touching transformers for PLP tasks, and we're starting with Python and Java. We have been able to put together about 387,000 files for our training corps, and we're mostly using PyTorch and a bit of Mindspore. As for server part, let me invite my colleague Andrey to talk about that. Ni hao to everybody. Andrey again from Huawei. Tanya, thank you for the intro. A very exciting plugin. And one day, coders will be just drinking coffee with donuts while the machine writes the code. One day, yeah, truly an exciting time to come. Let me say this. I would like to thank Tanya's team for actually agreeing to test Huawei Gear for this project. And let me talk a bit more for technologies that have been used. An ecosystem, Huawei for AI, Atlas platform, and on this slide you may see all of the ecosystem. You may see that Huawei delivers all of the components necessary to turnkey develop end-to-end AI app. That is DaVinci architecture, that is Neural Accelerator based on the block of matrices multiplication. We have scalar and vector units. We have server-based solutions for chips, Ascend 3.9 for inference, and Ascend 9.10 for more resource-hungry computations. This platform is available for mobile devices, smart cams, and most of the Huawei products, network devices alike. So now we're speaking about 310 and 910 chips. Those are system-on-a-chips, which are meant for AI and neural accelerators. I mean, a ton of vendors are going that way now. And this is a Huawei solution. 310 chip is a system-on-a-chip for inference, which is most optimal in terms of power to performance ratio. This is a device for smart cameras, for drones, etc. 910 chip is better productivity, but more power hungry, specifically for training. Training of models, like the ones that Sber develops also. And based on these system-on-chips, there is the average column that you see in the presentation. Devices. Edge Station Atlas 500, the device that allows to work, for example, at production in some harsh conditions in the street. For example, a camera that is working in the street at -15, protected against dust. That is the card to install into server for inference, for training, and Atlas 200 modules, which you can use to build an end-to-end device, like a drone or a smart cam. And of course, servers. We have two special lines over there, the line for inference and the line for training. All of these product lines are using developments from Huawei, CPU, based on ARM architecture, and neural accelerators branded Ascend. Also, you can use servers to build the entire powerful cluster, like Atlas 900, the AI cluster that is used to train bigger models. On the next slide, you'll be able to see that in more detail. And as for software, first of all, we are trying to expand community in Russia, and I would like to thank teams like Tanya's team for participation. We're going to make it more popular. We're working with educational institutions and universities, and we're generally open for collaborations, etc. We also have Model Arts platform. So you don't need to deliver hardware locally to your lab. You can use the cloud instead, write models, store datasets, etc. In addition, let me mention MindSpore, that has been already talked about a lot. That is a framework from Huawei optimized for our neural accelerators. They also support Ascend. In addition to that, we support PyTorch and TensorFlow by all means. So in this particular project, we have been using PyTorch because the team found it convenient to work with. I mean, we could do it very quickly, and I truly hope that we'll continue our research for MindSpore as well. And also we have CAN, that is the API, the language, the deep-level, low-level programming languages that have functions to work with hardware using Python and C++. To go into more detail for this project, We used one server, Atlas 100. This is a server for training. You may see how it's been built. 4-unit server split into 2 motherboards. One with neural accelerator. At the bottom, 8 neural accelerators. And on top, the motherboard of general functions with 4 Kumpeng and 920 CPUs based on ARM. So let me highlight that Huawei has the so-called Open Lab in Moscow, where you can see all of this gear. You can see it live, all of these chips, etc. And you can connect to it remotely and try and test it. And test some real-life cases using it. So to continue about the server, 4 Kumpeng, 4 ARM architecture, memory, and the most important thing with every neural accelerator, there's a 100 gigabit Ethernet for communication within cluster based on RoCE interface, which allows to put together these servers into a large system, training larger models. And this server consumes 5.6 kilowatt, which makes it overall an optimal solution in terms of volume of a data center and computational power, meaning that we can have the same rack but make it more powerful. And this server we have been using for this project. So, as for success history, we have been actively doing this in Russia, only starting, but in China there are a lot of success cases. And for example, one of the success cases is Panchang Lab in China, a national research center for large-scale model training on Chinese language. They've put together this cluster of servers. They're called Atlas 900. And its computation power is 1 exaflop for 2020. So, and they're going to extend this to 16 exaflops. So, this is, as I have already said, the large-scale model training on Chinese language. There is a similar problem there because both Chinese language and Russian language are not so popular online as English, for example. That's why there has been this common problem to put together a data set, a decent data set to train the model. And they have collected 1 terabyte of data in Chinese language. And they have used 2,048 cent chips. All of the chips in this cluster were put together in a unified system, so the model was trained distributed on these devices. You can learn about it in more detail if you read the corresponding article. It's out there available. Please don't hesitate to read it. And this cluster is leading now amongst the IPER 500 ranking and IO 500 ranking and others, other rating dedicating to supercomputers and HPCs. This is a success history, and let me say a couple of things about Model Zoo. The colleagues have been talking about that, but specifically, as for our project, Tanya approached us saying that we need a transformer-based model, and the starting point was Model Zoo, the collection of Huawei models, verified, well-proven. There are a number of models for computer vision, NLP. We have taken Transformer for this task and use it as a starting point. Of course, it's a big task. I mean, it requires more data. We're going to continue this work and keep training the model. We would like to thank our partners for solving the task together with us. I would like to ask Tanya to tell more about results. Yes, thank you. So, what's happening now is we keep on using Ascents. We're now training our transformers. We're using 8 NPUs for that. We just had first experiments using Python, and you may see our initial results for the function. So for now, we have been training transformer with the length of 128. We'll see what we get. I think the future is bright. Another thing that we're going to do here, we are going to add a number of languages. And after we train all of the transformers, we will be training them for business tasks, what they called downstream tasks. Search for vulnerability, speech-to-code, code classification, etc. There are more and more tasks like that. There is a number of open benchmarks for ML models and datasets. This is a very actively growing research community. Andrey probably have something else to say. We have a multi-cluster approach. Probably that's something to mention. Yes, indeed. We wanted to test. I mean, we're now only using one server. We would like to put together a number of servers. Locally, in OpenLab, we're putting together this cluster of 4 servers to demonstrate it. I think it will be very exciting to do it with Tanya's team. And we would like the team to try Framework MindSport, see its advantages, see how it looks like with our help, probably. I think that will be especially interesting for us, and we would like to do some sort of demo of the plugin, I guess, that we could be using for VS Code or something else. See how that works. Probably that's it? Yes, indeed. I think we're ready to answer your questions. We have the time for that. Thank you for your attention. Yes, indeed. Thanks indeed. There's a number of questions. Hopefully we'll see the answer. Hear the answer. Yesterday at the award ceremony at the AIJ context, we were talking about the creation of multitask model that will be able to solve tasks of different modalities. Will it be possible to use MindSport to work with them? Let me say a couple of words on that. At the AIJ, we had a big hackathon in the meantime, Fusion Brain Challenge. And the task of the competition was to solve a number of tasks with number of modalities. We had 5 of them minimum, and code was one of them. There's an image, table data, code, and text, and something else. As for MindSport, indeed, I will add, MindSport is a universal framework. There are well-known approaches which can be used. Multi-modal approach is just the mix of several units of text, like introvision, like text. But similarly, they can all be separately. They can all be solved with MindSport, so it's fully applicable. Thank you. Okay, since we'll start the conversation, can you tell about Pencheng in more detail? Is there anything like this happening in Russia? Pencheng is one of the labs in China, and indeed, China is known for its very own centers. Huawei is a tech partner for the program, but also in Russia, Huawei is ready to be a technological partner for this sort of events with somebody, if there's somebody who wants to do it. I mean, we're open to participate. In Nizhny Novgorod, for example, there is a research lab of Huawei, a big one, open. Maybe they're going to do some AI center there. We're working on that. Is there something like this in Russia? Will it be? Maybe. The answer is that we're ready. We're ready. Huawei is gladly going to participate as a technological partner. Why only Python and Java? Probably that's a question to me. For us, that were the most demanded language, which were easier to experiment. There's a ton of data in open access. There are good ratings at repositories, best repositories that you could use. By all means, the range of our languages we're going to expand, and there are no obstacles to make it based on C++. I believe that this task has this sort of civilizational, educational value, meaning that it can help people to learn to work with code and put down the threshold of entry into the profession, because the profession is hard. I believe that this will be mostly in demand amongst people who are learning to write code using C++, and we only began with something simpler like Python and Java. Final question. How do you evaluate the performance of NPU? Oh, let me answer this one. If we speak about Atlas Ascend, here's what our approach is. We are taking a particular task from a partner, like with Tanya's team, for example, and we're delivering gear, hardware, it's available, and we have a set of basic models, and the user can either select those models using hardware and look at the performance and everything that he or she is interested in and be sure that the productivity is there. I mean, it's sort of a test drive approach. Thank you, thank you. These were all of the questions. Tatiana, Andrey, thank you for participating in our live. Dear friends, thank you for your questions, and we will continue. Thank you!